Hassler here. I'm going to work through the 7-7 extension. This is something that we will do together as a class, and then your homework will be to work on the 7-7 extension homework to take the skills that we talk about in this lesson and apply them. So we now know how to find different types of points for quadratic functions. So let's put it all together. And we can find those different types of points, such as an x-intercept, y-intercept, the vertex. No matter which form we are in, whether we are in vertex form, standard form, factored, or intercept form. And so today we're going to be doing a little manipulating between standard and intercept form to help us get some of these important points. One says use the function f of x equals x squared plus 4x minus 12 to complete the following. So this is an equation given in standard form. It says find the x-intercepts of the graph and then graph. Now notice that I'm going to do all of this without Desmos, and in the end, we can go check Desmos to see how well we did, okay? All right, I'm going to go like this so I can see all of the parts for problem one. All right, so find the x-intercepts. Well, in order to find the x-intercepts, I first need to say that that's when the y is equal to 0. And remember, that means that I'm going to take my function output and I'm going to replace that with 0. I cannot pick out the x-intercepts when I'm in standard form, but I can pick out the x-intercepts when I'm in factored form. And so I'm going to go ahead and factor this. I notice there's no number in front of x squared, so I don't see a GCF. And so I'm going to break x squared up into x and x. I need factors of negative 12 that are going to add up to 4. And I'm thinking maybe 6 and 2. I know they need to be opposite signs. And since the middle number is positive, the bigger factor is going to be the positive number. You can do a quick check to make sure that you've got this. So 6 times negative 2 gives you negative 12, so that's your constant. And then if the outside pieces, if that negative 2 gets paired with x and the 6 gets paired with x, I'm going to add those up and I get 4x. And that matches the middle. So I know that I factored this correctly. So you can always do that quick check, or you can always do your box method to fully multiply out. All right, from here, I know that if I'm trying to multiply to get 0, then either this factor has to be 0, so x would have to be negative 6, or this factor has to be 0. So x would have to be 2. And again, these are the x-intercepts. And so I really have 2 points. I have a point at negative 6, 0, and a point at 2, 0. So I'm going to go ahead and plot those. All right, next it says find the axis of symmetry and graph that axis of symmetry for this function. There are actually 2 ways to find this axis of symmetry. And so I'm going to talk about both ways. First, I could average the x-intercepts. So this is something that we've talked about a couple different times, is that the axis of symmetry should be directly in the middle of these two. So some of us can eyeball it and say, I think the middle is going to be here at negative 2. I think that's where the exact middle is. But sometimes it's hard to kind of eyeball that. And so you could average the x-intercepts. Averaging means I'm going to add the 2 numbers together. And since I'm adding 2 numbers, I'm going to divide by 2. And that gives me negative 4 divided by 2, which is negative 2. So yeah, eyeballing it or finding the average is helpful. The other way we could do this is saying that x equals negative b over 2a formula. And so negative, now coming back up here, my a value is the coefficient of x squared, so that's 1. My b value is the coefficient of x. So negative 4 over 2 times my a value, which is 1. And so I get negative 4 over 2, which is negative 2. And so 3 ways to get this axis of symmetry. Eyeball it, right? This should be exactly in the middle. So I'm 1, 2, 3, 4 away on the left, and I'm 1, 2, 3, 4 away on the right. And so yay that I eyeballed it, or I could average the x-intercepts, or I could do negative b over 2a. So many options, all right? But now let's just find the vertex. And here's the deal. We found the axis of symmetry, but the axis of symmetry is also the x of the vertex, Okay, so the axis of symmetry is the x of the vertex. If I want the y of the vertex, then I need to put that number into my f function. I need to evaluate my function for the number 2. That means that I need to replace all of the x's in my equation with the number 2. And I'm going to type this into my calculator and calculate that. When I do that, I get negative 16. So your vertex should be written as an ordered pair. The axis of symmetry is the x coordinate, negative 16 is the y coordinate. And so I'm going to have a point right here for my vertex. It says find the find the y-intercept. I'm going to box that off. Find the y-intercept for the graph. And remember, the y-intercept is when x is 0. And the other thing that I recall us talking about is that anytime I'm in standard form, the y-intercept is that constant. A reminder that I'm substituting 0 in for x. And when I do that, these first two terms become 0, that becomes 0, that becomes 0. And you're just left with that constant. That's my y-intercept. And so y-intercept is where you cross the y-axis. Part E says plot one more point that is guaranteed. And I know from this symmetry that if my y-intercept is 1, 2 away from the axis of symmetry, I can be 1, 2 away on the other side of that axis of symmetry. So one more point that is guaranteed is this negative 4, negative 12. And now I have these 5 points that I can connect to make this beautiful parabola. The one other thing I want to say is, erase this up here. I got a lot of mess up here. The one other thing that I want to say is that I know this is going to opens up, and I know it's going to open up because this a value is positive. So way long time ago when we talked about transformations, we said that if the leading term, that a value is negative, it gets to open down. But because the a value is positive, a is positive, I'm going to open up. And if I open up, that tells me that my vertex is a minimum. Okay, I have a lowest point. So these are just some comments that I want to make because they're questions that might be popping back up at us. All right, so let's take this another step further. And we found all the pieces. 2, though, says solve the quadratic equations. And I look at these and I think, I don't even know where to start. Solve the quadratic equations. So I'm actually going to come back up here and I'm going to remind you that when we were working on finding the x-intercepts, we were able to find values for x, right? We were able to find solutions, numbers that would make that particular equation equal to 0. Those were my solutions to the equation. I had an equation. Solutions are the answers for x. And so I'm going to keep this in mind when I come back down here, and I'm going to think to myself, okay, if I want to find the solutions, my job is to figure out what x is going to equal. Those would be solutions. If I can find x values that make this side equal to 4, then I found solutions. But up above, the reason why I was able to find those x values is because my equation was set equal to 0. I'm going to make a note. We need to set equal to 0. And currently, this equation is not set equal to 0. I'm going to draw my bar here. And so in order to get this set equal to 0, I would have to subtract 4 on both sides. Now it matters where I put that 4. That 4 will not be combined with x squared. The 4 will not be combined with 11x. But it can be combined with the 34. So I'm going to line those up. When I do that, I get x squared plus 11x plus 30 is equal to 0. And now I'm going to say, yeah, I can do this. I can factor this. I can factor this into 2 groups equal to 0. So x squared is broken into x and x. Factors of 30 that add to 11. Oh yeah, 5 and 6, right? 5 times 6 is 30. 5 plus 6 is 11. And now I can say, yeah, I need to know when x plus 5 equals 0. Well, x plus 5 equals 0 when x is negative 5, so that's a solution. And I need to know when x plus 6 is equal to 0. Well, x plus 6 equals 0 when x is negative 6, so that's a solution. And so, yay, I found some solutions, but I want to go check to see if this is right, and I'm going to do that by using Desmos. And so what I'm going to do in Desmos is I'm going to type this left side of the equation in my first bar, and I'm going to type 4 in my second bar. So let's see, we have x squared plus 11x, and then we have plus 34, okay? And then over here I have, I'm going to say y equals 4. I think if you just type in 4, they're not happy about it. So we're going to say y equals 4. And I'm going to look for where they intersect each other, okay? So it looks like I'm intersecting here, and the x value is negative 6. What that means is if I put negative 6 into the left side of this equation, negative 6, the output is 4, and that matches my equation. If I put negative 6 into the equation, I get 4 out. All right, let's check this one. Oh, look at that. The solution here, x is negative 5. That means if I put negative 5 in for x here, I get 4. Well, that makes sense because it tells me I would get an output of 4. And so that means that we found the solutions, okay? So we can still use this factoring to help us find solutions as long as I'm set equal to 0. So let's do this one over here. Again, I'm going to draw this bar. I'm able to factor as long as I'm set equal to 0. So I'm just drawing there. I need to set equal to 0. So that means that I need to subtract this 8x on both sides. Now, the 4x squared and the 8x cannot be combined. They are not like terms. And so I'm just going to rewrite 4x squared minus 8x equals 0. Okay? And I notice that I don't have a constant, but I do have a GCF. It looks like they both have 4 in common, and they also have an x in common, okay? So I'm going to divide that 4x out. And if I divide this by 4x, I'd have 1x left over. And if I divide this by 4x, I have a minus 2 left over equals 0. Okay, so I want to find when 4x would be 0. Well, that happens if x were 0. 4 times 0 is 0. And I want to find when x minus 2 is 0. So x minus 2 is 0 when x is 2. Okay, and again, I want to do my little Desmos trick. I want to go ahead and graph the left side and the right side, and I want to see the x's where they intersect each other. So I'm going to close these ones out. Let's see. All right, so I'm going to type in y equals 4x squared and y equals 8x. And let's see where they intersect each other. So it looks like I have an intersection at 0, 0. When x is 0, I'm going to have equal values on both sides. I'm going to get 0 on both sides. So that should make sense. If I do 4 times 0 squared, that's 0. And if I do 8 times 0, that's 0. So yeah, I get an equal equation. I got to kind of move this, though, to get the other one. So let's see. This answer is 216. Now, we found that x was 2. That matches. The 16 means that if I were to substitute 2 in for x, I would get 16 on this side. 2 squared is 4, times 4 is 16. Yeah, okay. And if I put 2 in for x on the right side, 8 times 2 is 16. Yeah, if I put 2 into this equation, I get 16 on both sides. Okay, so we have two things happening here. One, we can use all the things that we know now to graph parts of the parabola. Part of that is factoring to get the x-intercepts. And two, I can solve equations with quadratics by using this factoring idea. The key here is, though, that before I can factor, I first have to set equal to 0. And then I can use that factoring idea that 2 items multiplied together to give you 0 means that one of those 2 items had to be 0. All right, so your job is to work on the 7-7 extension homework. And if you have questions, let me know.